You're listening to Let's Talk AI.
Welcome to our podcast today. Today's person we're interviewing is Vijay Ganesh. Vijay is an associate professor at the University of Waterloo's Electrical and Computer Engineering Department. He is also cross-appointed with the David R. Cheriton School of Computer Science and is the co-director of the Waterloo Artificial Intelligence Institute. Prior to joining Waterloo in 2012, he was a research scientist at MIT, and he completed his PhD in computer science from Stanford University. So welcome, Vijay Ganesh.
Thank you, Harold. Thank you for this.
So Vijay, we're thrilled to have you as part of our podcast today. And I just want if you could start and share with us some of your background and how you got involved in AI.
Okay, so I did my undergraduate degree in electrical engineering back in India a few years ago. And then I followed that up with working in the industry actually for a few years. I worked at Texas Instruments and Larsen and Toubro, which is a big Indian engineering company. And Texas Instruments, that's a big multinational company that makes digital signal processing chips. And subsequent to that, I went to Stanford, completed my master's and PhD, master's in electrical engineering and PhD in computer science, and then joined MIT as a scientist, followed by Waterloo as a professor. And all along, my interest was in primarily in logic, which I developed as a graduate student at Stanford. And then, given my background as an electrical engineer and given my background as a person working in the space of um, design and verification of um, microprocessors, I started applying my knowledge of logic to verification and testing and analysis of microprocessors. And then more recently, I've started working in combining logical methods with machine learning methods to solve problems that either domain cannot solve easily by itself.
Okay. So, but AI itself, how did you get into the AI?
So, artificial intelligence has two broad branches going all the way um, back to the origins of AI as a field. One branch is logic, and the other branch is machine learning, broadly speaking. And these two fields have developed relatively independently. Um, and there have been many phases in the development of AI technologies, AI as a field. And for some of the phases, logic based methods were dominant, whereas for others, machine learning based methods have been dominant. More recently, machine learning has been very dominant. And my vision of the future is how can we combine these two classes of methods to solve problems that cannot be solved otherwise. Just like in the human brain, we combine logical reasoning with pattern matching. Can we do the same on the computer?
Okay, Vijay, great. Thank you for that. So then let's just dive in a little bit deeper. Tell us more about your area of expertise and how it relates to artificial intelligence and machine learning.
So, as I mentioned, my area of expertise is logic and applying logical methods to testing the reliability and security of software and hardware systems. And more recently, I've also started applying it to AI. So the question is like, what is logic? What do we mean by that? And basically, it's quite easy to understand if you reflect on the point that human beings use logical reasoning all the time. We use symbols, we use abstractions to reason about the world around us and to solve problems. And a big question in logic over the last 100 years has been, can we somehow um, algorithmize logic? Can we put it on a computer? And if we could do that, then we could solve many problems that otherwise would be very difficult to solve. And this idea goes all the way back to Leibniz, actually. So Wilhelm Leibniz was this great mathematician 300 plus years ago who actually co-invented calculus along with Isaac Newton. And one of the questions he posed was, is it possible to automate human reasoning so that we don't even need lawyers? Even legal arguments could just be done using computers. I mean, he didn't use those terms, but he had the kind of the core intuition. And it took a long time until Alan Turing came along to come up with the idea of a computer. And Alan Turing is this amazing historical figure because he not only uh, developed the underpinnings of what we understand as a computer today, the foundations of computation as a field, the mathematical foundations, but also he went on to build one of the first computers that cracked the Enigma code, which helped the Allies defeat the Axis powers during World War II. So he was this amazing historical figure who made amazing scientific contributions, but also um, played an important role at one of the inflection points in history. So coming back to logic, so logic is about how do we formalize our reasoning and put it on a computer. And once you're able to do that, then you can use that to solve all kind of problems. You can solve, you can figure out ways to verify the reliability and security of hardware and software systems, but also you can imagine building knowledge bases. You have a company, and the company has a huge amount of domain specific knowledge. There's a lot of people who have a lot of knowledge about the workings of that business. How do you put that together in a way that the computer can reason about these um, different parts, different domain specific knowledge that different people have, put it all together in one box, and then combine that with machine learning, which is about pattern recognition and statistical reasoning. And so once you combine domain specific knowledge with statistical reasoning, you get something very powerful. And that is something that I want to accomplish, and it has not yet been accomplished in its full scale.
So I've heard that AI is a lot from a high level, an excellent prediction tool. What you're proposing today and blending logic with it, that's like a whole new kind of prediction.
Totally. And the reason logic is so important and human knowledge is so important is because um, pattern recognition can go wrong. So there is a very famous story about pattern recognition going wrong. And that famous story is called the Black Swan story. And the idea is this: what happened when the Europeans first landed in Australia, they were stunned to see this new land and they saw many new kinds of animals. But the most stunning animal to them was a black swan, because to them, swan was white. So, from a pattern recognition point of view, if you only have seen white swans, then you might conclude that a swan must be white. But the existence of a black swan is like a counterexample to that. So it tells you that the conclusion, all swans must be white, is incorrect. And in fact, this story has become so important, or has taken on a cultural significance, because in statistical reasoning, in financial predictions, market predictions, people use this term black swan event. This is like once in a lifetime event that contradicts your best theories. And because of, for example, the 2008 market crash was called a black swan event. And uh, and the people who build these theories to predict markets have to worry about the possibility of black swan events. So coming back to logic and combining logic with statistical reasoning or pattern recognition, What logic allows you to do is it allows you to debug your conclusions which were based off of pattern recognition. And if you can put that in a loop where logical reasoning is used to debug statistical reasoning or pattern recognition, then you get a degree of power that you did not have previously. And that's where I want to go next with AI.
Okay, great. So, from the outside, AI is growing so rapidly across, a broad sectors. What do you see are some of the biggest opportunities ahead for AI?
Yeah, so part of the reason that's fueling the growth of AI is the availability of data. And data is like money. It's even actually more valuable than money. So companies are storehouses of data. But companies are also storehouses of knowledge. And where I see AI going forward is the combination of knowledge specified symbolically with data or algorithms that can process the data. That's where the future is going to be. So one area within this domain is neurosymbolic AI, which uh, talks about combining symbolic or logical reasoning with machine learning. So that's one possible direction. In terms of kind of market opportunities, I'm not a business person, but I do kind of try to keep track of where AI is getting applied. And I think health is one huge area where AI is still at the very beginning of getting applied, and that's one domain I believe that is going to grow very rapidly in the future. And again, there the this idea of combining domain knowledge, that doctors or radiologists and nurses have with actual data and checking each other, the database, the statistical reasoning based methods, checking the knowledge that doctors have, and doctors checking the conclusions that you come up with using these statistical methods. They each of them debugging each other, is where I think the future lies.
So this is going to be a real help and assistance to the doctor, not replace them.
Exactly. Of course not. I don't think that's going to happen anytime soon.
And this will help with their diagnosis, prognosis, looking at the various symptoms and things and putting together a more accurate interpretation.
Totally. And also the doctors gain this knowledge through experience, their own experience, and talking to their colleagues and reading articles and so on. But having this another tool in their toolbox could be something that can collect the knowledge over a period of time from a variety of sources and bring it all together into one box. And they could query that system to get an additional check on their diagnosis, for example.
Okay. So if we look at industry, there's small companies, medium, and large. And if you could just walk us through maybe some example or guidance for, the SMEs, the small companies, the mediums, and the large. How do they get started? How do they embrace this?
Well, one of the important things um, for them to do is to figure out or to realize that they are valuable at many levels. These companies are storehouses of knowledge and data. They're not just producing products, but rather they have this knowledge and data that other people want. And if they can figure out a way to monetize that in a way that's compliant with the values of our society and compliant with laws and privacy issues and so on, I think that opens up um, a way for them, opens up a new economy altogether, in which not only the Googles and the Facebooks can participate, but your local company down the road can also participate. So that I feel, this idea of, how do we take care of the data we generate? How do we store it? How do we preserve it? And for that, and how do we monetize it? And I think a good step to making this concrete and practical would be for them to connect with researchers at places like University of Waterloo, where the researchers would be happy to discuss and solve problems for SMEs who do have this storehouse of knowledge.
Okay. So I want to just reference a quote by Peter Drucker. He's an incredible, business consultant and an advocate. He said, "The best way to predict the future is to create it." And yourself, you're a co-director for the Waterloo AI Institute. In your mind, how are you going to help create the future for Waterloo AI?
Well, as a scientist, we look into the future, we develop these technologies that are 10, 20, 30 years into the future in our labs. Um, but additionally, as a co director, it gives me an opportunity to connect with people in the real economy and understand their concerns and understand what they need and tailor our solutions that we develop in the lab to the problems that real companies face today. And so it gives me a unique perspective in how can I speed up, how can I hasten the reality that I want to create. Instead of waiting for 20 years, I can get it done in 2 years. Um, because I understand now, oh, here is my idea of combining knowledge and logic on the one hand with data crunching algorithms on the other. Here is a opportunity to help this company accomplish that goal. Maybe not in its full power, but maybe tailored to that particular company's needs and goals and and their resources. Um, so uh, that enables me to s- significantly speed things up in ways, create the new reality, if you will, faster than I would have otherwise been able to do.
So Waterloo AI has over 225 researchers, and in your role as the co-director, you're a conduit, to help get the projects, the expertise between industry and them connect. And if you could elaborate a little bit further on how do you see being that conduit?
So my role is to go and talk to companies, understand their problem, and then convert that into a language, into a research opportunity that would attract researchers within our members to work on that problem, and then provide that connection between the company on the one hand and the researcher on the other, um, and also educate. So that's the one thing, is to kind of understand the problems of industry and communicate that to the researcher, and understand the language of the researcher and communicate that to the industry people. But also, there is an education component where we can tell people who work in the real economy to tell them about different technologies that are out there, what their capabilities are, what their shortcomings are, and what are the new opportunities out there. So, to this effect, to this end, we actually conduct a lot of what we refer to as reverse co-ops, where industry people attend seminars given by our faculty members, or courses that are we offer. We support the offering of online courses which industry people can attend and take. So those are the ways in which we enable this symbiotic relationship between industry and our researchers.
Okay, so one last thing I have for you here. You know, Waterloo AI prides itself on really doing applied research for partners. How would you define applied research in your words?
Well, so applied research always has, I mean, I think the hallmark of applied research is that there is an application that you're working on, and you are crafting a solution for that application. You're pulling in together different kinds of solutions that are available out there and creating a new solution that would then solve that problem. On the other hand, with foundational work, you are asking like very fundamental questions, which may or may not immediately connect with applications out there. So fundamental questions such as, is it possible to have a computational device that has the same capability as humans in terms of intelligence, which is a very general question, and you need to kind of break it down into smaller questions. And then can we um, have a system that can see just like humans can see? Can we have a system that can understand language just like humans can understand? Can we have a system that understands mathematics just like humans? Can we have a system that does uh, can we have a computational system that can automatically discover scientific laws just like humans do? So these are more fundamental questions. But with respect to applied research, you're like, okay, here is a problem. It might require algorithms from different parts of AI and different parts of computer science to be put together in order to solve that problem, which is very application specific. So that's how I would distinguish applied from foundational.
Okay, well, I think we could wrap up from there. I think that's a great thought. Appreciate your involvement today with our podcast, and maybe in the future we'll reach out and do another one.
All right. Thank you, Harold. I really enjoyed it. Bye bye.
Okay, have a great day.
Bye.